Hello friends, welcome back to another Quantum Quandary video. Happy Merry Christmas. Very festive today. Anyways, we are going to show all the trigonometric addition formulas, double angle formulas, blah blah blah, everything you can think of today. And we're only going to use these 4 identities. So to get started, we'll find sine of x plus y. So I plug that into the Euler formula, e to the I x plus y minus e to the minus I x plus y. And so now what I want to do is I want to factor this, e to the ix, e to the iy, minus e to the minus ix, e to the minus iy, over 2i. So I need to make this a product of and a sum of sines and cosines. So I guess my best bet is to first divide them up. E to the ix, e to the iy, minus e to the minus ix, e to the minus iy. Okay, and now I can use just the other Euler identity. Of course, I guess maybe I can write that here. E to the ix is obviously cosine x plus I sine x. I mean, this is the one that you use to derive sine x and cosine x anyways. Okay, so this is 1 over 2i. We'll have cosine square, we'll have cosine x, cosine y, plus cosine. There is an interesting thing here, right? This guy is just this guy conjugated, so if this is z, and this is z conjugate, so I'll only have the imaginary parts left over. So I hope you guys can see that. So this will shorten our procedure a lot. E to the ix is cosine x plus I sine x. So the imaginary terms that survive are I cosine x sine y plus cosine y sine x. Okay, and then we subtract cosine of minus x and sine of minus y, but sine of minus y is just minus sine y. Maybe I'll write that. Cosine of minus x, sine of minus y, and plus cosine of minus y sine of minus x. Okay, so first of all, the i's will clearly cancel, so everything will be real, which we would expect. And then perhaps I will denote it like this. So this is cosine x minus sine y. So note that this term is positive after it's multiplied out, and it will add with this term. And then this is cosine y minus sine x. Again, positive, it will add with this term. So we're fine. Yep, we will get 2 of each, and then that cancels with the 1 over 2 factor. So it's equal to, oops, of course, black doesn't write on black. It's equal to sine x cosine y plus cosine x sine y. Okay, very good. So let me just, okay, we've derived the identity for sine x plus y. And now we're essentially done. Okay, let me copy paste this one. Very cool. Going to the next page, pasting the identity, and now I claim I can get pretty much any trigonometric identity from this one. Oops. Okay. So how about sine of x minus y? Well, this one's trivial. You just substitute minus y into y. So you get sine x cosine of minus y, which is just y. So I will write that. And then cosine x sine of minus y, which is just minus sine y. So there you go. Easy. Okay. How about cosine of x plus y? Well, that's just d by dx of sine x plus y, or d by dy, or d by dx plus y, whatever, as long as it's linear in the first argument. So it's going to be cosine of x plus y, yeah, but we're differentiating on the right hand side. So yeah, d by dx will be cosine x cosine y minus sine x sine y. Pretty nice, right? Cosine of x minus y, we'll get that the same way as we got sine x minus y from sine x plus y. So yeah, of course, just cosine x cosine y plus sine x sine y. Okay, trivial. Very cool. Next one, sine of 2x. Of course, substitute y equals x. We get 2 sine x cosine y. Okay, cosine 2x. How do you guys want to get this one? We could get it with y equals x. Okay, so cosine squared x minus sine squared x. We could also get it by differentiating sine of 2x and then dividing by 2. Yeah. Okay. I mean, it's pretty easy. Pretty simple stuff. Okay. Yes, yes. What else do we need? We would also like to get sine x plus sine y, right? Sine x plus sine y. Okay, so for this one, we might benefit from introduction of new variables. So let me just write sine u equals, okay, so you see we have sine of x plus y, we have sine of x minus y. So we'd like to use x plus y as u and x minus y as v. So x plus y equals u, x minus y equals v. Okay, so from this system I get that x is u plus v over 2 and y is u minus v over 2. Okay, and now I will have sine u plus sine v equals, so I'm just effectively copying these two parts, sine u plus sine v equals, so we'll have sine of x, sine of x cosine y. We have 2 of those, and then the other ones cancel. So 2 sine x cosine y, and then the other terms cancel. So now we just need to express x and y in terms of u and v. So this is 2 sine u plus v over 2 cosine u minus v over 2. Okay, good. Now, if we wanted to switch stuff around, we could differentiate with respect to x, right? So if I differentiate with respect to x, note that du by dx is 1 and dv by dx is 1. So if I differentiate it with respect to x, here I would just get cosine u plus cosine v equals 2 cosine x cosine y. And that's 2 cosine u plus v over 2 cosine u minus v over 2. Good stuff. Now, if you want to, let me just see if that's correct. Cosine u plus cosine v. Yeah, that's fine. Now, if you want to get sine u minus sine v, just substitute v equals minus v. If you want to get cosine u minus cosine v, now this one's a bit trickier. So yeah, I'm not going to do the sine u minus sine v. Let's see about cosine u minus cosine v. Cosine u minus cosine v. Yeah, I see. So you actually get it from by differentiating y. So in this first one, du by dy is 1, and dv by dy is minus 1. Okay, you see that? So if I differentiate this guy with respect to y, I'll get cosine u minus cosine v equals 2 sine x minus sine y equals 2 minus 2 sine u plus v over 2 sine u minus v over 2. Okay, very cool. Let me just add plus minus here. And the plus minus goes just into the arguments. Yep. Okay, that's the trivial one that I spoke of. Okay, is that enough for you guys? Do you want the tangents as well? We got the double angles. I wonder if the tangents are considerably more difficult or not.